Welcome to the Techniques of Digital Sets, Volume 2, Urban Cityscape Environments, Lighting and Texturing. This disc picks up from the conclusion of Volume 1, in which we set our scene up, examined modeling technique, and also camera work. This disc will proceed into lighting, and we'll show a number of different lighting approaches for digital sets and backgrounds, and then we'll begin to build our shaders and look at a series of techniques involving texturing. Okay, let's get going. The first thing we want to point out about lighting in digital sets is that of the broad spectrum of techniques that's required to do the work, lighting is probably the most key component of all. You could have incredible modeling, amazing animation, but the scene will just not succeed without very compelling rich lighting. It's also worth noting that lighting techniques for digital sets tend to be a little more specialized and different from the traditional use of lighting in CG and in cinema, for that matter, which involve themselves largely with lighting and illuminating the human face and or figure. And the use of a three-point kit, the standard kit, is not as relevant with digital sets. It certainly must be learned at some point. It is the foundation of all lighting, and some of the principles do remain, but lighting sets and backgrounds tends to be kind of a larger environmental issue of lighting rather than a more localized one with characters. And also global illumination must be mentioned with backgrounds and environments because it has been such a major revolution in the CG field for lighting. A lot of the techniques that were popular and used extensively even 5 years ago are shifting now to the landscape of global illumination. So we'll introduce kind of the old and the new in this disc and show what makes sense in a production workflow from GI. So there's many avenues of study for lighting in CG. There's theatrical lighting, there's stage lighting, there's product photography lighting, lots of different texts and treatises and all the kind of the range of lighting available. The best place for us to look, though, is lighting for cinema. Kind of the stage work approach is most closely allied with what we do in CG. So lighting in film is the art of the director of photography. The DP is responsible for the look and feel of the lighting, quality and mood set in the film. And from some workshops that I've taken with some DPs, I've found that their basic approach to this is that light is there to be modulated or molded into one of two expressions, either as hard specular light or soft diffuse light. And if you look at a lot of the technology of modulating light that, say, grips use, flags, cookies, etc., this is used to do just that, to sharpen light where it's needed or to diffuse it and let it wrap around in other ways. So we don't have these tools per se in CG, although GI begins to give us, with photon transport, allows us potentially some of these techniques. But nonetheless, without these tools, we at least need to learn have an understanding of how these tools are used and what the effects of that lighting is so that we can incorporate that into our range of tools in CG. But half of the battle in lighting is that of material definition. One thing about CG is that materials are inseparable from lighting. It's a little bit different from stage work where your lights, you're dealing with real-world materials that are relatively fixed, and then all you can do is modulate the light. In our case, we can modulate both sides, and that actually becomes of great benefit. It can be very confusing if you're not careful, but it's actually part of the real power of computer graphics. The downside is it's very easy to get unrealistic results because of that. It's almost would be nice if one could stay fixed. But nonetheless, that's also what we're going to examine here, is that lighting, again, just naturally bleeds over into shading. But ultimately, the goal of good lighting in CG, and actually any kind of lighting in the world, is that good lighting shows form, or expresses form, reinforces form through light and shadow. And if you consider that in a lot of your lighting, you'll probably get better results. Again, because good lighting psychologically reinforces your sense of form in space. And certainly working in 3D is the best medium to express that. So with digital set work and lighting, we have two basic approaches, that of exteriors and interiors. And it turns out that the lighting approaches for the two is fairly dramatically different. Exterior lighting is, again, mostly about expressing form and kind of revealing or separating form from its background to make it stand on its own. Lighting for interiors is very different, where it's more showing relationships and how everything is unified within a common lighting. So we'll get started in here talking about exterior lighting. And what I'm going to do is also divide it up between direct lighting, which is the old style of working with simple CG lighting, and then GI techniques. So our first topic here is exterior lighting with direct technique. So it's this is probably a good one to start on because this tends to be the easiest to accomplish. We can mostly rely on directional lights or spots with very narrow cones placed very far away to get relatively parallel sources, and oftentimes that makes good sense because your depth map is more controllable from a spotlight than a directional. But nonetheless, we're really just looking at simulating parallel lighting of the sun. So this really becomes an exercise in fill lighting and how to do that properly and fill shadowing. And we'll look at a few techniques for that. So we'll look at how to position the sun properly, how to match to live action plates, and this can be done with sun position charts or these days with a bonus tool called Sunlight. We also want to invoke warm and cool shifts into our fill and key, and this psychologically enhances depth to the viewer and the image and creates a richer depth. And then we also look at ways that we can do simple gobos and cookies with CG lighting with direct lights. So the first topic we'll look at in exterior lighting is setting up sun and fill. So this is a sample scene of a Indian stone temple, and we can look at a render of that here. And this is a useful model for lighting because it has a lot of surface relief and areas to show off lighting response, which is nice. So the classic method for exterior lighting is using a directional light for the sun source, a parallel source, and an ambient light for the fill. And we'll show why that's not a terribly good idea. But as far as setting the directional direction, if you have a time of day, if you're matching into a live plate, a time of day that you want to match, we'd use a sun chart. So a sun chart such as this is available through architectural texts if you care to find them. And they're fairly useful because you can locate a given time. So this is August 21 at 4:45. So we can follow this along 4:45. And this gives us both a longitude and a latitude, basically a bearing angle and an altitude. And I could reconstruct that my directional light settings to this and reconstruct that exact vector for that given time of day. Now finally, this was added into Maya through the bonus tool set. If we go to rendering, create sunlight, what we have here is a directional light created, and if I go down, it has extra attributes, which is latitude, day, and time. This is just in basic integers throughout, but as this changes, we can see that I can rotate based on a given time. So this is useful too. It's probably a more direct way of doing this. But again, an integration to live action plates, it's a useful little tool. Okay, so we'll rely on a primary directional for this lighting. And let's look at what ambient light and ambient fill does for us. So if first thing to do is to swing the light around to the backside, so now we have a face that we can examine and work with as far as fill. If we increase our ambient light, you can see why this is such a terrible idea. Ambient light should be avoided pretty much at all costs. There's a use for it now in ambient occlusion, But with direct lighting, it's really probably the worst offender of bad lighting. There's a uniformity to the fill, which is destroying any sense of form that I can find in here. So the better option is to create a cluster of directional lights on the lee side. So what I'll do is I'll duplicate this light around, and then we'll swing it around 180. And we'll duplicate it again. And we'll duplicate a few more times, and there's no rhyme or reason to this. It's really just a cluster of lights that diverge from the primary. Okay. So now if we go back to our renderer, this is what we have with the straight ambient, and now this is what we get with the directional cluster. So you can see the nice thing about all this is it's creating much more definition of the form within. And I think this is about 4 directionals. The other thing, it's good to throw a little bit of shadowing from them. So this has a very low resolution, I think a 256K shadow map. And that's just enough to create a little bit of welling of shadow so that there is some definition back here. And again, the fill shadow or the fill light color source should always be a cool temperature. The main key should always be a warm temperature. And we'll talk about that in a moment. But you can see that this is actually not a bad solution for sets and environments for just describing form a little bit better in fill. Now, of course, this is a direct technique with global illumination. HDR provides a lot of nice fill opportunities that we'll look at in a upcoming chapter. But again, if you want to rely just on direct lighting, this is a pretty useful technique. So the next step up from this technique is to use a light dome. And this is nothing more than a hemispherical collection of spotlights and or directionals. There's a great MEL script for this, G.I. Joe, available from High End, which automates this. What I do for basic lighting studies is I keep around a kit of 16 of these lights, and I import this in as a group. What you want to do when you import in this is let's scale it up according to the scene so the coverage is correct. So let's pick one of the spotlights. Let's look through selected. And now let's up arrow so that we have the scale of the entire group, and then begin to scale the entire grouping. And what we want to do is get enough coverage from each spot to cover the entire scene. You can use directionals here too. Spotlights are a little better because they're more controllable over what the shadow map will be. I can look in another spot here, and I can basically just go around and verify that I've got proper coverage. And anytime you work with shadow maps like this, it's always a good idea to look at the map in the render data folder in the project, Maya project, and use fcheck to inspect them. A lot of artists fail to do that, and it's actually a very good practice. So now that I have that set up in my scene in the proper size, I could at this point eliminate both my directional cluster and my ambient light, and now I can rely on the dome as my fill lighting and still use the directional light as a primary key. So if I look at the if I render this view, this is what I'll get. And if we go back to the other, I've raised my intensity a little bit so we can kind of see the shadow characteristics a little better here, but this is a much superior way of creating the fill than the directional cluster. A little more expensive. There's more lights, more shadow maps to calculate, but not too bad a hit. The nice thing here is that we do get a little bit better contact shadows on objects because we get more of a GI kind of grounding fill. And if I bring it down, I can then kind of match what I had previous. So let's take that image out. And I can see that this is a more naturalistic sense of fill light. It's basically getting into regions that the other one may not. So this is again a good basic way to go. And in the fill shadow chapter coming up, we'll compare this on our project with G.I. Joe and then some GI ray tracing alternatives or methods to the same end. So the next topic we'll cover with direct lighting is creating cookies and gobos with direct lights. And I could, cookies and gobos again in real life are erratically cut cards that are placed in front of key lights to kind of randomize the placement and also soften the light at the same time. In our case, we can do this by texture mapping the light, the color channel of the light, and we'll try that on this scene. So we can't apply a gobo realistically to a directional light because it suffers from the same problems as shadow maps, in that it will apply the map to the extents of the entire geometry of the scene. So it's better to have the control of a spotlight in this case. So I've created a spot. Let's take a look at this. And let's look through selected, and I can see that I've dollied out substantially to cover the range of the scene, and it is a 10-degree cone, so it's relatively parallel, but will give us slightly diverging shadows. So from that, what we'll do is we'll take the spotlight color and we'll texture map. Actually, let's go back one. We'll apply a image file to the color channel. And in this case, this is just a random collection of forms that I made in Photoshop. The important thing here is you don't want to apply a gobo like this without any kind of filtering. So the filter offset provides a significant amount of blur on a texture map, and it doesn't take much for me to get a fairly soft edge. The texture updating has seemed to be a bug in Maya in the last few versions, so it doesn't necessarily always reflect that. And then lastly, in the gain, I'll apply some warm coloration, and I'll also add a little bit of offset because I don't want the light to go down to black in between these regions. So I'll apply a bit of offset, and we should be good to go at that point. So let's look at a rendered from this, and this is what I'll get from a gobo. And if I compare this with the prior image, we can see this has a consistency of lighting across the scene. And this one now is more randomized and kind of blocked out in different areas, and it's just going perhaps a little too dark in these regions, but still providing a little erratic sense of light. And again, this imperfection is what will give your images much more realism. So nice idea to use this as a basic tool for exterior lighting. So here's another example of using the same gobo. This is a very early render of a architectural kind of subterranean space, and here we can see without the gobo and then with. And I think what the gobo does in this case is impart a bit more scale to the potentially massive scale of the scene. And by further texturing and developing the lighting here, I think it would be very beneficial. So a variation that I like on this technique is to texture map, rather than just a straight gobo, to actually texture map a form of noise to the light. So if we look at our spotlight again, in this case I've disconnected the gobo and I've put in a noise function, a 2D noise function. And the reason I like noise is because it now offers a number of different noise types. This was not always the case in earlier versions of Maya. And I found that billow is a very nice one for lighting purposes. It puts kind of a highly contrasted type of random noise. And the main thing that's important here is that the gain is set relatively high, also with quite a bit of saturation involved. But also the color offset, quite a bit of value. This is normally set at 0, of course, and now I'm raising it substantially, basically creating a higher pedestal for the light, so it's receiving a higher multiplication of the intensity based on this noise into the spotlight itself, and then the intensity of the spot is also a little higher than you would normally have it set. So what we end up with is a image like this, which again has randomization in the light placement. So again, we can see a little bit of noise artifacts in the darker regions here, but it's enough to just make the lighting less perfect again, and most importantly, create very brilliant highlights in particular areas where that multiplication is coming through. So if we compare this with the straight gobo, we can see this is again a little bit further developed than what we had. So it's a nice technique. And here's a few images from a project using the same rig. Here you can see the beauty about this is that we get these kind of hot spots and kind of a natural roll-off of lighting throughout the skyline. This one here again, we get a little focused hot spot, a little less here, and some random noise kind of scattered around the roadway. And again, just nice, sharp, tight highlights here to really drive the feeling of the sun. The next topic we want to cover in direct lighting is that of incandescent mapping and also thresholded shader glow. Incandescent mapping is one of the real underdogs, I think, of environmental lighting. It's a case where we can paint lighting rather than calculate, and in many cases it proves to be a nice route. Rather than expensive calculation, if you have decent painting or texturing skills, you may be able to give a much richer look to the lighting, a more erratic look also, than you may get through sheer computation. So let's take a look at one example of this. This is a project which required potentially hundreds, if not thousands, of lights. This is a large spaceport seen from above, and the prospect of having to illuminate this conventionally was rather daunting. So what we chose to do was spend all the time on a texture map. This is a base for a planar projection over the model, and put our time in painting what we felt like the light should be for the scene. And then when it gets applied back on, we arrive at this look. And this is really devoid of virtually any CG lighting. There's hardly any in this scene, so it's virtually all done as painted light. And of course, it's a very efficient render, and that's one of the beauties of this technique. Now, there's no ability to interact with this lighting because there is no real lighting. It's really just a shader hack, but nonetheless, for environments, a lot of times that's not really an issue. So in this case, incandescent mapping can work very well. But let's go ahead and show a very simple setup for how this is done. All right, now let's illustrate the setup of an incandescent map. To do this, I have a very simple wall surface. If I go in, I have a very basic texture of a weathered surface onto it with a bump and a spec map, and that gives me this result, which is the starting point. Now what I want to do is provide a wash of light. I'll have it emanate from below, and we'll see how we can do that with texturing and not with lighting. So we'll start by going into Photoshop with a texture, and from here we'll go to Filter, Render, Lighting Effects. And this is a filter that you may have looked at before and thought it had great cheese potential, but in our case, it can actually work pretty well to simulate CG lighting. So in this case, I'll have a basic wash of a spotlight. I can add multiple spots. I can add omnis, a lot of similarity to CG lights. The important thing here is that by default, the slider on ambience is set at 8, and what this will do is you increase this, is it'll provide an ambient light fill outside of the lights, and we want to reduce this down to 0 because because this is just piped into a channel in the shader, we don't want to provide an overall incandescence just relating to the spot. So we'll accept this, and we'll save this out now. Okay, back in Maya, I'll go to my shader, and under incandescence, I'll apply that as a basic surface map. And what I want to do is I can use the gain here to control the intensity of this light. Okay, and when we go to render, we want to make sure we turn our source light off. In this case, we're relying on lighting from texture, not from light. And if we look at the render that we get from this, we'll see we have this result. So it does a fairly faithful job of bringing it over. If we provided any CG light in the scene, we'd have that contributed into the shadow area and not into the incandescent area, so that's a very useful thing. But one thing that we found we lack here from the original is any sense of bump mapping. The fact that the bump map is present, but it has no CG light to respond to. We'll have to bake this into the texture as well. So we'll go back to Photoshop, and we'll undo this effect, and we'll go back into Render Lighting. And we find that there's a texture channel, which is in effect a bump map, and we can choose one of these, and we can choose an intensity here. So as I accept that now, the bump is effectively baked into the incandescent map. I'll resave that out. I'll go back into Maya, and we'll get this. So from our original, where this bump map now responds to a CG light, we have a texture that responds to the texture light. Okay, so that's a very simplistic setup, but at least it shows you some of the issues of how to get that started. Here's another example of incandescence now, and being used almost extensively. This project was kind of tooled for real time, so it made good sense to bring the lighting in as texturing, but virtually all the lighting in this is done as incandescent mapping, so it can be a useful thing primarily for interiors, but can also be used nicely to augment conventional lighting. So the last topic we'll cover with direct lighting is that of thresholded shader glow. And again, this is more of a shader attribute, but it's a lighting related issue because it provides a sense of a lighting bloom. And obviously this example is a little over the top, but it does show the nice behavior that it can have. Again, specular blooms like this are often best done in compositing. Doing them in Maya makes some sense oftentimes because of matting issues, but in general can also be done as a glow pass, and that can be probably the best route to accommodate these. But let's look at the one aspect of this that does make it useful for backgrounds and sets. So to show this off, let's go back to the stone temple model, now made metallic, mostly for the reason of having a very concentrated speck that will display the shader glow. If we open up the shader attributes, we'll see under special effects there's glow intensity, and as we raise this, it will in fact create a bloom over the entire object. But the problem with this is just that, it's washing over the entire surface rather than just the specular highlights. The trick to this is if we close this out, we go to the shader glow global shader parameters here, and this is a way for us to control either the color or the behavior of glows across the board in the entire file. But we're not really going to deal with this. We're going to deal with one parameter, which is that of threshold, which is the key. So as we threshold up, it begins to reduce the glow down just to the speck highlights and allows us to put a nice kind of blooming behavior over the object. So this is a bit of an adjustment between the intensity of the shader glow itself and the threshold to find kind of the sweet spot. So I'll go back here to the shader glow intensity itself and begin to raise or lower that. So in other words, we could take our glow intensity down fairly low, but go back to our threshold, lower the threshold, and we can get a different type of linearity to the glow this way. So it can be a very useful device if you're going to render in camera in Maya. And another example of this kind of in action is in this space station model. And again, this is thresholded down fairly low, and there is a bloom occurring on these highlights. And again, it just provides a sense of a brilliant sunlight as opposed to a kind of weak CG light. And again, this is on the path to what HDR does naturally, HDRI lighting, which we'll cover next. But if you're playing the direct lighting game, this is one way to get a sense of intense contrast.